it is a situation that tends to not be quite as prevalent as other heart conditions, but definitely something you can and probably will run into once you get out in the field. So now, if we look at what we say is the gross anatomy, all right, and we don't mean like gross, ew. Well, I guess it depends on how much you like to cut stuff up. Okay, if you like to cut stuff up, you definitely don't go ew. Okay, but if you're not that much of a fan of cutting stuff up, I am. I love to cut stuff up. Okay. All right. What does gross mean? What we can see with the naked eye. Now, y'all ever seen like the pictures or videos or whatever showing like the heart beating within the chest? Okay, I just need this. Okay, now the heart. Okay, when they're talking about the heart wall, look at this area coming down and going around. Okay. We've already seen that this thing is encased in a sac with the little fibers holding it in place. Okay, so now take a peek beginning from this little inner portion to the outer portion. Okay, is everybody following me? Mm-hmm. Do you remember epi, endo, myo? Epi means what? Did I get that backwards? I think I did, didn't I? Outer, inner, epi, outer, endo, inner.
I thought so.
Because, yeah, you should have called me on that.
But that's what it says in here, too.
You should have called me on that.
But what you said matched with this. It just confused
epi
me.
referring to that it was the outside of the heart.
Oh, okay.
Okay, so, you should have called me on that. Okay, so, endo, inside, myo, middle, epi, outside. Okay, so now, take a peek. Kind of look at this inner portion, okay? So take your heart, if you've got the other part of it, all right, because you can also look on this portion of it, okay? But what I want you to see what they're trying to represent. Do you see this kind of really flesh color that they're using? And it looks like it's kind of more smooth type, okay? And note how they've got it running along the structures on the inside, okay? So, endocardium, lining interior of the chambers. Simple squamous epithelium. Do you happen to remember what that structure was like from part 1? Simple told us how many layers? 1. Okay? Squamous tells us what shape. Does anybody remember? Flat. Well, to me, they look like fried eggs because they look like a flat cell, but the nucleus kind of bumps out a little bit. Okay, so that's what squamous looks like to me. It looks like fried eggs. So it is a single layer of flat, or as I would say, fried eggs. Okay? This endo. Now, granted, in this little model that we have, okay, note this portion that looks like paper, and I think it is, okay? I think it's some kind of paper. That is representing valves. If you flip it upside down and look at it from this direction, you see some valves, looks like 1, 2, 3, 1, 2, 3, okay? Those are also valves. So now, endo is going to also be covering the valve's surfaces. That that is going to be continuous with what we'll soon learn is endothelium, meaning that inner side of a vessel. What I've just told you, this structure has created a very nice closed system. Okay? So what I've just told you is that we have a closed system because I'm going to go back to what I said earlier. We're going to see this has to work on pressures. All right? And oof, is that fun? Okay? So we've got this closed system. We're now going to have the ability for it to work on pressures. So now, if we take a peek from endo, moving outer, this middle portion, okay, that is my myocardium. This is the point. I have my actual cardiac muscle. So what I've just told you, this is the point where the heart has the cells that can contract and relax. Because the myocardium is made up of the cardiac muscle. Okay? Now, the way that we say this is done, most of the time when we think of the heart beating, all right, go back to the picture that I got you to bring up in your head from a video, seeing it in a chest, okay, where it looks like it's going boo boom, boo boom, boo boom. That is not what happened. Each individual cardiac muscle cell is contracting and relaxing. They do it so well coordinated that it makes it look like one action. But really, what is happening is it's going to start here, and it's literally going to, it twists, all right? It goes, you're going to find out why, okay? But it's not going boom, boom. Well, it is. That's what it looks like. But the actual activity inside, cardiac muscle-wise, is all right? Now, that makes for an extremely well-coordinated movement of blood from both atria to ventricles, ventricles to great vessels. Okay? Really cool. Trust me on that. So, the outer visceral, because it's going to run along the contours of anything that's on the inside here. Okay? So that's the visceral. That one, serous membrane, external heart surface, mostly simple squamous epithelium. So now, what I've told you is the working part of the heart is my myocardium, the middle portion. Okay? We have what's termed a fibrous skeleton, fibrous skeleton network, which is, I think, what they were, that picture that you had. What they were trying to represent. Okay. So, this is going to be a framework of, do you guys remember collagen and elastin? Okay. Collagen, tough, very little ability to stretch and recoil, but elastic does. Elastic has a better ability to stretch and recoil. So we've got two fibers now in the structure that give support and the ability to stretch and recoil. So the majority of it concentrated around the valves. Go back to the ones I pointed out. Atrioventricular, semilunar. All right? It gives structural support, but at the same time allows for opening of these valves. It helps to anchor cardiomyocytes, cardiac muscle. It is also for electrical, hold up. Stop it all right there. What do I mean in this organ by electrical? Think back to your BIO141 when you were talking about muscle and nerve, skeletal muscle, nerve muscle. What made an action potential occur? Our ions. Do you guys remember those? Hopefully, in part 1, you learned about their movement across the membranes, and that would cause either the skeletal muscle to contract or the nerve to send an electrical potential, action potential, maybe? Is that how you may have heard it? Okay. Now, we are still talking about muscle. Okay? This time, cardiac muscle. For this muscle to contract and relax, we're going to depend on movement of ions. Meaning, we'll once again have action potentials. Aren't they fun? So, we're going to see that this fibrous skeleton helps with an electrical insulation. Think about electrical wires in a wall. Electrical wires are not exposed. If anybody knows anything about electricity, they're not exposed. They are insulated. Why?
To contain the electricity?
Well, you got to have the conduction that will occur, and it's not a good idea to have those exposed. Maybe end up in a whole bunch of fires, electrical fires. Okay, insulation is important. Okay, so insulation between atria, upper portion, ventricles, lower portion. Okay, because you can see that they're trying to show a difference between atria to venture